Hello everyone, thanks for tuning in. We're going to talk about Math 100, section 1.1 today. And we'll start off with a definition. Exponents. What are exponents? Exponents are shorthand for repeated multiplication. Sometimes we need to multiply the same number by itself repeatedly. That's how we use exponents. Let's take a look. 5 to the 4th power. 5 to the power 4. What is this going to be if I want to write it out as a multiplication problem? Well, it'll be 5 times 5 times 5 times 5. The exponent 4 tells me I want 4 copies of the number 5. Which, if I multiply together, 5 times 5 is 25, times 5 is 125, times 5 is 625. So 5 to the 4th is 625. What about 3/5 to the 4th? Well, I'll follow the same convention, right? 3/5 to the 4th is 3 over 5 times 3 over 5 times 3 over 5 times 3 over 5. Notice 4 copies of the number. 1, 2, 3, 4. The number in question happened to be a fraction, but that doesn't change the rule. Now, if I want to multiply this, we multiply straight across the top. 3 times 3 times 3 times 3. 3 and 3 makes 9. Times 3 is 27. 27 times 3 is 81 in the top. Over 5 times 5 times 5 times 5. We just said 5 times 5 times 5 times 5 is 625. And that might take a little bit of convincing, but that is in simplest terms. That will not reduce. So we can circle it up. 3/5 to the 4th power is 81 over 625. Now, how about the last one? 0.023 to the 4th power. How will that look? 0.023 to the 4th power. Well, I'll write 0.023 parentheses 0.023 parentheses 0.023 parentheses 0.023. Notice I used parentheses because using the dot symbol for multiplication with all those decimal symbols can get a little cluttered, right? So I chose to use parentheses instead. Now, multiplying this, while I'd love to multiply it in my head, I think it'll behoove us to use the calculator. 0.023 times 0.023 times 0.023 times 0.023 equals, oh, I've run into an error. My calculator doesn't have enough digits to calculate it. So what would I do? How would I calculate this number if I was required to? Well, you can't, right? If the number's too small, we can't calculate it using the technology at hand. That's not always possible. So, not calculable. That will happen sometimes. Not very often, but when dealing with very small numbers, we can be limited by technology. Same with dealing with very large numbers, we can be limited by technology. Now, what is the actual answer? Well, if we actually were able to calculate it out, it would be 279841. It would be 6 zeros and then 279841 would be the actual answer. Very small number, right? Very, very tiny. So sometimes numbers might not be calculable because they're so small or so large. That doesn't happen very often, and don't expect that to come up until we get to chapter 5 and start talking about scientific notation again. That will be when we start dealing with very large and very small numbers again. For the time being, we'll deal with more manageable numbers like the first two examples. Now, how about order of operations? What's the order of operations? Now, a lot of you are probably thinking PEMDAS, or maybe if you're a European student, you might be thinking BODMAS. Forget that. PEMDAS is incorrect. It is not the true order of operations. It helps us remember the order of operations, but it is not the correct steps. The order of operations has 4 steps. The first is work within, I abbreviated, the grouping symbols. Which, if you need reminders, are parentheses, brackets, braces, grouping symbols, right? You work within the grouping symbols. That's the first step. Some people like to think of this as the P for PEMDAS, parentheses, right? The second step is apply exponents. We apply exponents. That's the E in PEMDAS. So we do group symbols first, then exponents. The third step is we multiply and divide in order from left to right. So this is MD or DM. You multiply and divide left to right. If division comes first on the left, you divide first. That will trip people up a lot because PEMDAS looks like you always divide after you multiply. That is not true. Multiplication and division have the same importance. You do them at the same time. In what order? Left to right. Think about it like this. Multiplication and division are opposites, right? So they happen in the same step. They're related. They have a relationship. They have to happen simultaneously. Similarly, in step 4, we subtract and add in order from left to right. So this would be the AS or SA in PEMDAS. So the 4th step is we subtract and add from left to right. And same thing, addition and subtraction are opposites, right? So they get combined in the same step. That will trip some people up. Some people always want to add before they subtract. That's not right. Those are the same importance. They happen at the same time. I put a little note here just so we're aware. Multiplication has a lot of symbols. 3 times 5 with the little X symbol. I generally tend to avoid the cross multiplication symbol because it looks like the letter X, which, as you know, comes up a lot in math. The dot, 3 times 5. I tend to prefer the dot, but I avoid the dot when working with parentheses. When working with decimals, because then I prefer parentheses notation. We will use all the notations. We'll go back and forth between them, get comfortable using the different notations. Multiplication has a lot of symbols. So, let's walk through a boatload of examples just to get used to the order of operations. It may help you to keep this page open so you can see the steps as I talk about them. So, 24 minus 12 divided by 3. I skipped the first step, no groups. I skipped the second step, no exponents. I'm immediately on multiplying and dividing. I do this first. So that gives me 24 minus, what is 12 divided by 3? Well, that's 4. And then 24 minus 4 is 20. Nothing too crazy, right? How about the next one? I got a grouping symbol. I do that first. So I've got 9 parentheses. I work this group first. 6 plus 11 is 17. So I do 6 plus 11 first. Then I want to do 9 times 17, which would be 153. So I multiply after I've added. I do the group first. How about in number 3? What do I do first? Well, there's no groups or exponents, so I immediately skip down to step 3. I'm multiplying and dividing. What order do I go? Left to right. So I'll do 6 times 8 first. That gives me 48, and then I copy everything else down. 5 times 2. Now I do the next multiplication. I go left to right with the multiplications, right? I don't add next. I'm still multiplying. I have not moved to the addition step yet. Gives me 48 plus 10, which gives me 58. Then I move into my next example. 48 divided by 2 times 3. There's no grouping symbols and there's no exponents, so I immediately move on to dividing and multiplying. Which do I do first? Well, I go left to right. I am going to divide first. I don't multiply first. I go left to right. Always left to right. So 48 divided by 2 is 24, and then I still have that times 3 floating on the end. And then only one thing left to do. 24 times 3 gives me 60 plus 12 is 72. So I get 72. That example trips a lot of people up. A lot of people don't like that. However, in order for the rules to be consistent, it's important that multiplication and division happen at the same time from left to right. Otherwise, the answers won't necessarily work out the same every time. That's why it's an order. That's why there's a specific order. We have to match that order. Now, how about number 5? 16 minus 3 parentheses 2 plus 3. So this right here, in the parentheses, I got to do first. I get 16 minus 3, parentheses 2 plus 3 is 5. I've worked my grouping symbol. There's no exponents, so I'll skip to multiplication. Here's some multiplication right here. So I'll keep the 16 minus 3 times 5 is 15. And now I'm ready to subtract, which gives me 1. Notice, even though the subtraction was the first thing we saw, it was the last thing we did, because it was the last step in following the proper order. How about this next example? We've got a group right here. So we'll start off with step 1, groups, right? So I get 2, parentheses 5 plus 6 is 11, and I copy everything else down how it was, 7 times 3. Now, I move on to exponents. I finished my group. I got no exponents, so I go to multiplication. I start here, because I go left to right. 2 times 11 is 22, and I copy everything else down. I'm still in multiplications. I move to this multiplication next. I don't add, I multiply next. 22 plus 21. 7 times 3 is 21. Now I add, is the last thing to do. 43. So I went step by step, right? I did one step at a time. In our 7th example, we have our first appearance of an exponent. There's no grouping symbols, so I'll skip right to the exponent step. 9 plus 2 to the 3rd. 3 copies of 2, right? That's what the 3 means. 3 copies of 2. 2 times 2 times 2. 2 times 2, 4, times 2, 8. So 2 cubed, or 2 to the 3rd, whichever you prefer, is 8. And then I have that minus 5 trailing. Now I've done my exponents, I move on to multiplying. I'm done with multiplying, there was no multiplying. I move on to adding and subtracting. I'm going to add first because it's on the left. 9 plus 8 is 17, minus 5. Only one thing left to do, and that 17 minus 5 gives me 12. So I went one step at a time again, right? I did my exponent first. My last example, I've got grouping symbols. I've got this bracket and this parentheses. Now, with grouping symbols, you work inside out, right? You work with the innermost group first. So I work with this 6 plus 5 first, and then this second. So this 2 out front is just chillin'. 8 plus 3, parentheses, 6 plus 5. The first thing I want to do is 11. Now, where do I go from here? I'm done inside this parentheses, but I still need to sort out this bracket. Which step do I do first, addition or multiplication? That's what's right here, right? I've got plus and times. Which comes first? Well, times comes first, right? I want to do 3 times 11 next. So I've got 2, bracket, 8 plus 3 times 11 is 33. Now, I'm still within this bracket. Notice I've been trapped in these brackets for a while now, haven't I? Maybe it feels like March Madness. I got to add up this last step in the bracket. So this 2 still just chilling out front. Bracket. 8 plus 33 is 41. And now I'm ready to work with this 2. What symbol is here? Multiplication, right? Whenever a number is written next to a grouping symbol, it's multiplication. 2 times 41 is 82. So I get 82 as my final answer. Notice we just walked one step at a time, right? We go one operation at a time. I strongly encourage you, just like I did on this page, to work one step at a time for the time being. As you build skills and confidence, you can start taking more steps in one line. But for the time being, you want to make sure you're doing everything correctly. You want to go one step at a time, just like we did here, until you get that confidence to then move more quickly through these problems. Practice first, one step at a time, though. Now, parentheses, brackets, and braces are not the only grouping symbols. Those of you that have already watched our R.1 video know fraction bars also separate numbers into a top group and a bottom group, the numerator and the denominator. So let's look here. Let's look at our example. We have 4 parentheses 5 plus 3 over 3 times 2 minus 1. Now, where did that blue pen go? Never mind. I dropped a blue pen. We'll skip it because I don't feel like re-recording. So, the top. 4, 5 plus 3 plus 3. That is one group. I am going to work out what answer is in the top separately from what answer is in the bottom. I'm going to treat them as 2 separate groups. Then, in the last step, I will work with the fraction bar. So, let's look at the top. What do I do first in the top? Do I work with the 4 times? Do I work with the 5 plus 3 or this plus 3? I do the 5 plus 3, parentheses first, right? Which gives me 8 plus 3. I'm going to leave the bottom blank for the time being because I'm going to keep figuring out the top. 4 times 8 plus 3, I do multiplication before addition. 32 plus 3. Notice I've still got the bottom blank. And then I get 35 for my numerator. So I figured out the top number. Now separately, I'm going to work on the bottom. 3 times 2 minus 1. 3 times 2 is 6. Minus 1 is 5. And then I'll just bring it over because there's nothing to do with it in this last step. I'll bring 5 over. So my fraction reduced to 35 over 5, which, hey, 35 over 5, that divides evenly to the number 7. So 7 is the answer to this expression. That is what it reduces to, the plain old number 7. Notice we treated each part separately, right? We kept them separate. because they're separate groups. We have to work within that group, the numerator and the denominator separately. The last step, we dealt with the fraction bar. A great way to think about big fraction problems like this is treat it as two separate problems. Here's problem 1, here's problem 2, and then at the very last step, we combine the two halves. So, let's move on to one last definition and then some examples. Our last definition is inequality. An inequality is a statement comparing two non-equal values. In equality, they are non-equal. They're not equal. It's comparing two values that are not the same. For example, 7 is not equal to 8. Oops, 8. 7 is not equal to 8. That is what this says. How about the next one? 7 is less than 8. 7 is less than 8. We can go from words to symbols and vice versa, right? How about 5 is greater than 2? 5 is greater than 2. What's this one say? This one says 6 is less than or equal to 6. This is the less than or equal to symbol. And then, last but not least, 2 is greater than or equal to 1. 2 is greater than or equal to 1. We've got inequality symbols. We've got 5 of them. Not equal, less than, greater than, less than or equal to, and greater than or equal to. Now, what's an easy way to remember them? I like to remember the symbols by thinking about them like Pac-Man. If I drew a Pac-Man here, Pac-Man will always eat the bigger number, right? If I put a 8 here and an 11 here, which way would Pac-Man want to eat those numbers? Well, like that, right? So 11 is greater than 8. That is a way to remember the numbers. Maybe an alligator if you don't like Pac-Man. But it helps you remember which way the inequality symbol is supposed to be facing. Think about Pac-Man eating the bigger number, eating the larger number. And that brings us to the end of section 1.1. Thank you for tuning in, and I will see you next time.